Well, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hope you guys had a good weekend. We had a test on Monday, and that's the main business of today. We're going to actually go through the test. Just as a reminder, I believe you should be going through lecture 14 today. So after this, at some point, you should be watching lecture 14. That being said, we kind of have a whole test to get through, so let's actually let's just jump into it. So the plan is to pretty much, because we have limited time, is that I will go through the test and you guys can actually stop me if you have questions. I might ask for your input every now and then, but for the most part, just to make sure that we can get through everything in the time, maybe even get through the bonus problems if we're lucky. I'll kind of just go through it and you guys can let me know if you have any questions. Okay, so test one, here we go. All right, so I think everything is set up. I can see the chat and everything. Okay, cool. All right, let's get into it. So this was test one, and we're pretty much going to go through it, let you see what the answers are, why those guys are the answers, and you guys can stop me if you have questions. So here's problem one, how it started. Reduce to lowest terms. So we spoke about this, what it means to simplify rational expressions. Basically, the main game in town is to factor and cancel common factors. So I would start out by, let's call this F. Okay, so F is equal to, I would try to factor the top and factor the bottom. So of course, these are both monic. So two numbers, when I multiply, I get 60. When I add them, I get -4. I think 10 and 6 should work. Make it a -10 and a +6. For the bottom, 12 and 4, maybe like a 6 and a 2 can work, and make it a +6 and a -2. These guys would cancel over here, and I would be left with x -10 over x -2. And that seems to be the third option right here. So that's that one. Hopefully there are no questions on that. If you have any questions or you don't understand what I'm doing, you just stop me, just holler. Moving forward. So this is something that we've spoken about before as well. The idea of what it means to rationalize. Here we want to rationalize the denominator. There's a cube root in the denominator. So just multiplying divided by the same thing by changing the sign is not going to work. We want to take advantage of the difference of cubes formula. So we do know that if we have a minus b, if we multiply by a squared plus ab plus b squared, this allows us to cube the a and cube the b, and that's what we want. So we want to be able to multiply by something that's equivalent to this. And by looking at what we have here, that's this guy right here, right? With a equals x to the 1/3 and your b equals 1. So that's something that you didn't really have to even use any calculations for, just a concept check, essentially. Moving on to question 4. Well, technically it's question 3. Question 1 was the instructions and the honor code and all that stuff. Okay, so moving on to the third question technically, but it's actually Q4. We want to combine to a single expression. And we kind of know how to do that. We just have to create a common denominator, right? So that's essentially what we're going to do. So notice here that we have 2ab over a minus b times a plus b. Now I'm factoring the denominator so I can see what factors are missing in the other guys. So when I look at the second one, I notice that there's an a plus b missing in the denominator. So I'd multiply this by a plus b over a plus b. Then when I add the 5, I'll notice that the entire denominator is missing. So I'd multiply by a minus b, a plus b, and on top, I'd write this as a squared minus b squared, so it's easier to multiply out. Yeah, and so now I would have 2ab minus, I'd multiply this out, minus ab minus b squared plus 5a squared minus 5b squared all over a squared minus b squared. And now I want to try to clean this up a bit. Okay, so I have 5a squared. That takes care of this guy. I have 2ab minus ab. So I would have plus ab. That takes care of those two guys. And I would have minus b squared minus 5b squared. So that's minus 6b squared. And we have that. Do we have anything that looks similar to that? Not really, but they do say simplify. So let's make sure that this can't simplify further. How do we go about doing that? Well, let's ignore the b's for a second. So just think of this in terms of the a's only on the top. So if I had 5a squared plus a minus 6, would I be able to factor that? I put a 6 here and a 1 here. That would give me, on the outer multiplied would give me a 5, the inner multiplied would give me a 6. So I can make this a positive 6 and a minus 1. Then we attach b's to each side. And that's actually the factoring of the top. Now I notice that this cancels, which is why we don't really multiply out the denominator. We want to see when things would simplify. So an even simpler version of this is 5a plus 6b over a plus b. And that's the second option. So for this, we know we want to do the fractions are being divided. So do the whole keep, change, flip idea. So we're going to keep the first one. Change this to a multiplication and flip the second one. Now, sometimes while I'm doing this, I'll be factoring at the same time, but I'm doing it one at a time, so you can see what I'm doing, as well as sometimes if you realize that when you're doing two things at once, you make mistakes, you want to actually just slow it down a little bit for the test, so you don't just make needless mistakes. And at this point, we want to try to factor everybody. Hopefully everyone factors. Let's actually see. All right, so you start with the first one. It looks like 2 and 1 should work. Plus and plus. For the bottom, 3 and 1 should work. Yeah, that seems to work. Okay, so for the top one in the second fraction, 3 and 1 also, but the 1, I would say, has to be negative here to get a -3. I'm missing something here. That should be a 2, because otherwise that wouldn't have factored. And no, not that should be a 2. This should be a 2. So 2 and 1 works here. Make this a +2, make it a -1, and that seems to work. Now you go through and you start canceling everyone. So the Z plus 1s cancel, Z minus 1s cancel, Z plus 3s cancel, and these guys cancel. So everyone kind of cancels. We end up with just 1. It's a very fancy way to write 1. Okay. Are we doing okay so far? Everyone alive over there? Thumbs up, sign of life. Okay, cool. All right, so far I'm not saying anything crazy. Everyone's like, okay, I see what you did. And yeah, I agree. Okay. Remember to stop me if you have any issues. And here's a problem. You have to show your work for this problem. There were a few of those. I don't even remember if I saw some of it. Yeah, the last one was also. So for this, you have to show your work. So when it comes to grading, not only did you have to choose the right thing, but your work had to make sense. And, so I'm still working on actually fully grading the tests. Like I said, I expect to have your grades out by Monday, but it'll probably actually be a little bit earlier, maybe by the end of today or tomorrow, in fact. And when all those detailed gradings are done, I'll let you guys know. All right. So state the domain of this function. So we know for rational expressions, one of the first things we look for, it's not the only thing, but one of the first things we look for is where the denominator is going to be 0. Now, individually, the numerator and denominator are all polynomials, so there is no other issue other than the denominator being 0. So pretty much I just want to know where the denominator is being 0. So the only issue. Only potential issue is a 0 in denominator. So this means I want to look where x cubed minus x would be equal to 0. We know that to solve that equation, we need to factor. And that can be factored further. Right, so this means if our x is 0, we're in trouble. If our x is 1, we're in trouble. If our x is -1, we're in trouble. And for these guys, we need to avoid them. So on our number line, where we see 0, -1, and 1, those guys need to be avoided. So we need to not be that, not be that, not be that, but everything in between is okay. So that leads us to from -infinity up to -1, then between -1 and 0, then between 0 and 1. Right, so that's what I'm talking about here. I'll check them off as I'm doing it. From -infinity to -1, from -1 to 0, from 0 to 1, and then from 1 to infinity. So there are 4 branches here, and those are them, and we take the union. So that looks like this 4th option here. Okay. Okay, evaluate the expression when x minus 3, x plus 3 divided by x squared minus 9 when x equals 3. Notice that when I plug in x equals 3, the denominator is 0, so it's undefined. None of the above. X equals 3 makes denominator 0. So not allowed. So that was another one where it was sort of a concept check there. You didn't really even have to do anything. Just notice that the denominator would have been 0 and you're good. Okay, want to make sure that you can compute a difference quotient. It's going to be important in Calculus 1. Now there's going to come a point in Calculus 1 where at the end you want to plug in h equals 0, but I'll let your Calculus 1 teacher explain to you why that's the case, which is why when you want to simplify these guys, you actually want to, one of your main goals is to actually cancel the h in the bottom, because you eventually want to plug in h equals 0 to achieve something. But in the meantime, let's actually figure this out. So this is that. So our f of x is 7 minus 6x minus x squared. So what I would do is for the f of x plus h, it means I replace every instance of x with x plus h in parentheses. So I would have 7 minus 6 times x plus h minus x plus h squared minus parentheses, very important, often forgotten, 7 minus 6x minus x squared. So that's the first step. A lot of people who get problems like this wrong mess up on the very first step. Let me actually move this over a little bit more. And of right now, you can just continue simplifying this. So I'd start expanding parentheses here. So 7 minus 6x minus 6h. This is going to be x squared plus 2xh plus h squared, but I'm going to distribute the negative. So ultimately it'll look like that. Now I'm going to see guys that I can actually combine. So we have 7 minus 7. We have minus 6x plus 6x. We have minus x squared plus x squared. And that's all we can combine. So now I have minus 6h minus 2xh minus h squared all over h. Want to simplify this, can't cancel across sums. I would factor out a common h. These guys would cancel. And so I'd be left with minus 6 minus 2x minus h. And that's this option here. Someone's just coming in. Let them in. Okay, for this one, we want to factor completely, right? So it's already kind of half factored. Now I want to factor it even more. What we can do, notice that in the first pair of parentheses, there's a common factor of 4. There's a GCF of 4, so that's the first thing I would pull out. So I pull out a 4. Let me change color here. Pull out a 4 from the first set of parentheses. I'd be left with 4x squared minus 1 times. Now in the second one, I can also pull out a 4, it looks like. And I'd be left with 3x squared plus 7x plus 2. Okay, so I can, now for this one, I can move the 16 out here. This one I would actually think of as 2x squared minus 1. And this one is just, well, 3x squared plus 7x plus 2. So this is actually a difference of squares, 2x minus 1 times 2x plus 1. For this one, I think a 3 and a 1 is going to work. And if I put a 2 here and a 1 here, that gives me 6 on the outside and 1 on the inside. That would add up to 7. So, and that's fully factored. So this is a none of the above, but you need to show that this is the actual answer that you should get. Okay, share your work for this problem, solve this equation. We did a problem similar to this on the quiz prior to the test. So hopefully everyone paid attention to when I was working through that one, and this would be no problem. So when you see something like this, the trick is to expand everybody and bring everyone to one side and then factor and set each factor equal to 0, right? So that was the strategy. So I would expand the left side. That would give us x squared plus 4x minus 12. This means I would move the 7 over. That would look like minus 5. And now try to factor this. 5 and 1 seems to work. If I make it a plus 5 and a minus 1, that fits. So here my x is minus 5 or my x is 1. Third option. So that's that one. Now it says this problem may serve as a hint for the next problem, which means you could solve the next problem without even worrying about this. But if you paid attention to this, then it might actually help you for the next one. Okay, what is the best expression to multiply both sides by to transform to an equation without fractions in it, essentially, right? So we know that we want to multiply by the LCD. So we know that what we have here, to figure out the LCD, we'd want to factor, right? So for LCDs, we want to know the prime factorization. So for the first one, if I factor out a y, and the second one factors into this difference of squares. So notice that this is what we have. We have this, and so this means that the LCD, that minus sign looks like a tilde or a squiggly. Let's not make that L minus. Okay, so the LCD here is just going to be the product of everybody. Y times y minus 1 times y plus 1. Yeah, so that's this one right here. So that one you didn't have to show your work for it, but that's how you would have gotten it. Just factor all the denominators and then create the LCD from them. And it's y times y minus 1 times y plus 1. Now in the second problem, I actually asked you to solve that same equation. So if you went through the trouble of finding the LCD here, that should actually makes it easier to solve the equation for you. We have y plus 2 over y times y minus 1 minus 6 over y minus 1 y plus 1 equals 0. So this is what was given. Just rewriting it. But now we know that the LCD is this. So what I can do is I can multiply that by y times y minus 1 times y plus 1. And this is the LCD found in the last part. Of course, the other option would be to just combine the fractions on the left. You'd have to create the common denominator. Essentially, you'll be building up to the LCD anyway. So you'd just be redoing some work, but that was another option. So now if I multiply through by the LCD, right? So I'm going to take this guy, multiply that, and multiply that. So now we'd have the following. So the y times the y minus 1 would cancel in the first case. So I'd only have y plus 1 left over. So this ends up being y plus 2, y plus 1. Minus the y minus 1 times y plus 1 cancels in the second one. So I'd only be left with y. So that's just 6y equals 0. So I get to a situation where there are no fractions right away by multiplying by the LCD. Now this is just quadratic in disguise. We know how to do with those. Expand everybody first and refactor. So this is going to be 3y plus 2 minus 6y equals 0. This is y squared minus 3y plus 2 equals 0. 2 and 1 would work. So y minus 2, y minus 1. So this means that my y is 1 or my y is 2. However, remember, we always have to check these. This guy would make, if my y equals 1, I would reject because it makes denominator 0 in the original. This one, though, checks out. So only y equals 2. All right, people who forget to check their work would do that. No, in general, if you do something different, to answer the question in the chat, if you do something different and get to the same answer, as long as what you did is valid and mathematically sound, I don't care. So the only times when you kind of have to do it one way is if I put the instruction that you have to do it a certain way. I believe there was a problem where I did that. I don't. Was it on this test? I wrote so many tests in the past week. I don't remember if it was this test. So there are times when I put in the instruction, no credit given for any other method. I don't think I did that on this test. Yeah, so no, in general, I don't care, right? Which is why you might have recalled a few lectures ago when I showed you guys a bunch of ways to factor quadratics. I even showed you guys the payback method, which I've never used in my life. It's because I want you guys to know about various ways to do things and use whatever way works for you in general, right? So I'm not a stickler for, you have to do it my way, it's my way or the highway. There are a few times, in this class, I don't think it shows up very often, but especially in my Calc 1 class, I would do that. There are some times where I force people to do it one way, and that's just because there is going to come a point in the future where they have to understand that kind of process to be able to understand something. And so there are times when I force them, okay, when you're solving this problem, you have to do it this way, because if you don't do it this way, something in the future is going to confuse you. In pre-calculus, when you're dealing with the fundamentals, I don't particularly care how you get them done. Just make sure that you have a mathematically logical way to get them done. So yeah, in general, if I don't specifically state in the problem, you have to do it this way, no credit for any other method, then you can use whatever method. Okay, and that's even why I put in the instructions here. You'll notice that I said, this may serve, right? So my preferred way of doing this problem, which I think is the most efficient way, is to multiply it by the LCD, but it's not the only way to solve the problem. So that's why I said that, right? So anyone who's subscribed to my way of doing things, which I have good reason to believe it's the best way to do things, but I'm not going to force that down anyone's throat. They would use that here, and they would get to this situation right away with a lot less trouble. But no, there were other ways to solve this, and as long as you did it correctly, of sound mind and judgment and of strategy that's repeatable and logical, I don't care. And these are questions that you can bring up during class. So there are times when students can do something and they would get the right answer, but the method is actually completely wrong. And if they were in a different context, they would have gotten it wrong. So if you do something differently from me and you're not absolutely sure that this is a mathematically legit method, you can bring it up. Here's what I did. Is this okay to do in all situations? And I can actually discuss that. But in general, I'm not going to force you to do one way over another. Okay, let's look at this one. Solve the equation. So we've seen this before, or similar problems. What we would do here is we'd square both sides to get rid of the radicals, right? So I would have now, what you do not want, the common mistake would be to square all the terms individually. This is incorrect. You have to square the entire side. So this entire side gets squared and that entire side gets squared. Common mistake is to square all the terms individually. But that is actually a distributing powers across sums error. And I believe I did put some answer choices here that if someone were to square each term individually, that those are the answers they would have gotten, but they're actually incorrect. Common mistake is to square each term individually. Do not do that. This is wrong. Must square the entire side. Okay, so now when I square that, this kind of reminds you that now it's the radical of x plus 3 plus 1 all squared, which means it has to multiply out. So it's going to behave like a plus b all squared, which you should give you a squared plus 2ab plus b squared. And so that tells you how to actually expand the right side correctly. Whereas if you square each individual term, you're not going to get that. So here, the square gets rid of the radical. Here, I'm going to square the first term, and I'm going to get 2 times the first term times the second term plus the square of the last term. Now, if you square it individually, you would not have gotten that. You would have missed the middle term. Squaring each term would miss this guy. Right, so that guy would have been missing if you squared each individual term. So that and that would throw the whole problem off. So we've seen a situation like this before. This situation was on the previous quiz. The idea is now to isolate the radical. So I'm going to move everyone that's not a radical to the other side. So when I move over the x, I just have an x. When I move over the 3, so I'm going to move over the x, I'm going to move over the 3, I'm going to move over the 1. So that actually kills the 4 and one of the x's, and then I would have here 2 times the square root of x plus 3. Now I square both sides again. Remember, square the entire thing. This includes the 4. This includes the 2, which is going to give you a 4. I'll mention that as well. Common error is to not square the 2. And as I've been talking to several people over office hours during this week, I did mention that to them, like when you're going through and you're practicing a problem and you get it wrong, don't just be like, okay, I got it wrong, guess I need to try again. Let me start from scratch. Let me, what's the right way to approach this? And you go to a tutor and they tell you, okay, this is how you do the problem. And you're like, okay, yeah. It's very important that you go back to what you got wrong, find the position where you got it wrong, make sure you know why that was wrong, make a note of it. Hey, this is a common error. This is a mistake that I always make. And you need to write that down and say, okay, my mistake happened here. Here's the misconception. Because that's how you're going to learn. So it's not just a matter of getting a generic right answer. It's also important to know, when is your answer wrong? Why was your answer wrong? You as an individual. Don't worry about anyone else, because there are very common mistakes, but every person is going to make a different combination of the common mistakes. So you need to figure out what your particular misunderstandings are. So whenever you get a problem wrong, don't just crush it up and back to the drawing board. Actually examine what you got wrong and have someone examine, okay, where did I go wrong here? Because I got the wrong answer. I want to know why I got it wrong, right? So that's an important part to examine. So then you can come up with a list of mistakes that you personally make. And so now you personally will know what to look out for, right? So this is the personal part of study, is when you kind of identify common errors. So if you're making any of these errors that I'm talking about, don't just glance over them and say, okay, yeah, I know, I'll try not to do that next time. No, go through your work, highlight. It's even better to do it in a different color ink. Highlight, I made this mistake at this point, right? And really sit on that and really think about it, right? So then now your brain realizes, hey, that's important. It's important for me to pay attention to this. And so now you moving forward, you're rewiring your brain to think in a more correct pattern. Because if you just kind of glance over it, your brain is going, it's not important. It's just going to forget it again. You're going to make the same mistakes over and over and over. And then before long, you're going to be one of those students who are like, oh yeah, that's just me. I always make silly mistakes on tests. Well, that's because you're not actually structuring things correctly, right? So there are a lot of people who just think that's them. Like, I'm just a person who makes silly mistakes on tests. No, you can fix that, right? And the fix is to really emphasize the silly mistakes in your mind, build it up in your mind. So you say, okay, here's my mistake. Okay, I need to avoid that, right? And once you pay attention to it, your brain will automatically start to notice every time you're about to make that mistake, your brain will go like, haha, we did that last time, remember? And then you'll know to not do it, right? And before long, you'll realize that all your little silly mistakes get flushed out and you just don't make them anymore. So it all starts with actually examining where you go wrong, and worry about that. A lot of people don't like to dwell on their failures, but when it comes to actually learning something technical, it's actually pretty important. You have to go through, realize where you are wrong, why you are wrong, what was the better way to think about it, and that's actually going to help you in the future. So when I'm pointing out these common mistakes, go over the work that you did and try to see, did I make that mistake? I know I got this problem wrong, but why? Did I make any of these mistakes that Jhevon was talking about? And if you realize you didn't make any mistake that I was talking about, find out which mistake did you make personally, right? And then make sure to make a note of it, especially if it's a recurring mistake. You will find that there are some mistakes that you always make when you're in a certain position. Find out what those mistakes are. What is a common mistake for me, right? Anyway, too much ranting. We're going to keep going. We still have a lot to get through. What question are we on? Yeah, we're a little bit over halfway. So let's actually just keep moving. But I thought I'll just mention that because it actually came up a couple times in office hours when I was talking to students. Okay, so this is x squared. I would multiply this out. This is 4x plus 12. We know how to deal with this. Bring everyone to one side. And that arrow is weird. And try to factor now. 12, 6 and 4, 6 and 2, making a -6 a +2. That seems to work. So x equals 6 and x equals -2. Now remember, it's very important to check your work in this as well, because sometimes when you're squaring a radical, we saw this when you're getting rid of even radicals, because when you square something, you can actually just eliminate a plus or a minus sign. You want to make sure that you are getting the correct. So you do have to check both of these. So this. So now we need to check x equals 6. Okay, and we're checking in boom, this guy. These squares that I put in. So we have to check that this guy is going to work. So on this, on the left side, if my x equals 6, I would get the radical of 2 times 6 plus 4. That's going to be 12 plus 4. That's going to be radical 16, which is 4. On the right, if I plug in 6, I would get 6 plus 3 plus 1. That's going to be radical 9 plus 1. That's 3 plus 1. That's 4. So this one actually does check out. Now I want to check x equals -2. Okay, so let me squinch this up a little bit more. Maybe someone got kicked out just now. Okay, let's do this. These. Squinch this up a little bit more. Okay, so now I would plug in x equals -2. So this would become 2 times -2 plus 4. And this would give me, well, that's -4 plus 4. That's going to be 0. This one would be the radical of -2 plus 3 plus 1. That's going to give me radical 1 plus 1. That gives me 2. So this actually does not check. So x equals -2 is rejected, rejected. Or just reject, just keep present tense. We live in the moment. Okay, so just x equals 6.
I have a question for that one.
Yes.
Would it be wrong if we started off by moving the +1 to the other side, so it would be like the square root of 2x plus 4 minus 1 and then squared that whole expression?
No, it's in fact it'll be equivalent. There was no reason to do that. It'll just make your left side behave like the right side of my solution.
Okay, because that's
It'll
what I
actually be
did.
exactly equivalent, but you do have to make sure that your middle sign on the other side is negative.
Okay.
So if you did that, you would get 2x plus 4 minus 2 times the radical of 2x plus 4 plus 1 equals x plus 3. And then if you isolate the radical square again, you'd end up with the same quadratic that I do.
Okay.
Or you should. So if you don't, it means you made another error somewhere.
Okay.
But there was nothing wrong with moving the 1. In fact, moving the 1 puts you in a very similar situation, right? On one side you have a radical plus 1, and on the other side you have a radical. If you move the 1, on one side you'd have a radical minus 1, and then on the other side you'd have a radical. It's pretty much the same situation. So I didn't see it as necessary to move it.
Okay, because when I did that and I squared like the whole expression, I got radical 2x plus 4 minus 1 times radical 2x plus 4 plus 1. And then when I did that
then no,
out.
you did a difference of squares formula. That was your mistake. It wouldn't be difference of squares. You did the +1 and the -1, so that was incorrect. That's your mistake. You actually mixed up with the difference of squares formula. Let me just look at alternatively. Let's say you started here and you decided to move the -1 over. At this point, what you would have done is squared both sides. And now you would get 2x plus 4, so the square of this, minus 2 times this times that.
Oh, okay.
Plus that equals x plus 3. So it looks like what you did was the individual squaring. You thought of it like it was this squared and that squared, and then you did a difference of squares. Right. So you in fact made the error of the first one I made here. When you moved it over, you thought of squaring each thing individually, and then that brought to your mind, oh, that's a difference of squares, but it shouldn't have been.
Okay, because I still got the x equals 6 somehow, but I just didn't get the second, like the x equals -2.
Yeah, so that was a coincidence.
Okay.
Yeah, this would have been the correct way to proceed, and ultimately you would get the same quadratic that I did. Did you get another x value besides the x minus 2?
No, I only got like x equals 6.
Oh, so yeah.
So I guess I just lucked out with that one.
Yeah. Okay, moving forward. Okay, so here we wanted to solve an inequality. What does A needs to be for the solution to be that? Okay, so let's go on. Here we had 2x minus 1 plus A less than or equal to 10. We'd isolate the absolute value. 10 minus A. And we know when we have an absolute value less than some number, we can put the negative of that number on one side, put what's inside the absolute value in the middle, and put the number on the other side. Then I can, this is minus 10 plus a. I can add 1 to all sides. And then I can divide all sides by 2. So I would get here a minus 9 all over 2. And here I would get 11 minus a all over 2. And we were told what we want the answer to be. We want this to be minus 3 and 4. So we want this to be minus 3, and we want this to be minus 4, positive 4. So then you end up with 2 equations. A minus 9 over 2 equals minus 3. And you have 11 minus a over 2 equals 4. Both of these would have to work, so you just pick your favorite. A minus 9 would have to be minus 6. And so your a would have to be 9 minus 6 equals 3. And you can actually check this here. If a equals 3, does this actually work? 11 minus 3 all over 2. Well, that would be 8 all over 2, which is 4. So that works out. So a equals 3 works. Solve the inequality. So here, you would combine the fractions. Here, I just use that trick we had using, I know that if I have a over b plus or minus c over d, that's equal to AD minus BC over BD. So here I would have 2x minus 6 minus x plus 4. Want that to be greater than 0. So here I would have x minus 2 over x minus 4, x minus 3. Then set top equals 0 and bottom equals 0. So here you have x minus 2 equals 0. That gives you x equals 2. Here you have x minus 4 times x minus 3 equals 0. This means that your x equals 3 or your x equals 4. And now you just test it on the number line. So you'd have 2, you'd have 3, you would have 4. Now these guys, you cannot be equal to 3 or 4 because they make the denominator 0. And here you cannot be equal to 2 because you have a strict inequality. If it was a greater than or equal to 0, it could be equal to 2. So we're actually not allowed to be any of those guys. Now, in between, what we're going to do is we're actually going to test. So I'm going to plug in random numbers. So I can plug in like a 0 over here. I can plug in like a 2.5 over here. I can plug in like a 3.5 over here, and I can plug in like a 5 over here. And we're going to test this. So I'm going to test in x minus 2 over the x minus 4, x minus 3. Okay, and right now I only care about the signs, so I don't particularly care about even the values. So I just realized if I plug in a 0, the top is going to be negative, the bottom is going to be negative and negative. And that would leave me with, well, a negative. Here, if I plug in 2.5, the top would be positive, the bottom would be negative times negative. So that means a positive. If I plug in 3.5, the top would be positive. This would be negative, and that would be positive. So overall, that gives me a negative. If I plug in 5, the top is positive. That is also positive, and that is also positive. So this gives me a positive. So I know I want to be greater than 0. So we want the positives. So that's here works and here works. So this is a solution and that is a solution. So between 2 and 3 and then bigger than 4. And that's that. Okay. This one, it's just a linear inequality. No, not linear, but there are no fractions, so you bring everything to one side. So here we'd have x squared minus x less than x. I would subtract the x. Factor out the common x. And again, setting equal to 0, this gives me x equals 0. This gives me x equals 2. And now I just test this in the number line, 0 and 2. So I'll test a number like -1, test a number like 1, test a number like 3. And if I plug in -1, test in x times x minus 2 less than 0. Okay, so if x is -1, that's a negative times a negative. That gives me a positive. If x is 1, that's a positive times a negative. It gives me a negative. If x equals 3, both of those would be positive, which gives me a positive. And I want the negative. So here we want negative. In the original one here, we want positive. So between 0 and 2, and it's a strict inequality, so I'm not allowed to be equal to these guys. So that between 0 and 2. All right, simplify radical expressions. Again, we know the trick here is to open two radicals. Here we have a squared b, open two radicals. All right, so we go through each radical. We're going to put what simplifies in the first radical, put what doesn't simplify in the other radical. So 18 is actually 9 times 2. The 9 is going to simplify, the 2 won't. A to the 11, I can think of that as a to the 10 times a. B to the 7 is b to the 6 times b. And so that's the first expression. Now move on to the second one, the 32a to the 7b to the fifth. 32 is 16 times 2. A to the 7 is a to the 6 times a. B to the 5 is b to the 4 times b. So here what I have is 3 a to the 5 because it's an even power and an even radical. So we knew we get absolute values. B cubed times 2ab plus here I would have 4 a cubed b squared 2ab. Here I have the a absolute value of a squared times absolute value of a cubed. I have the 4 in the front, so that's absolute value a to the 5th. I have absolute value of b cubed, and I have that. Notice that these two now are the same. So it's like I have 3 apples plus 4 apples. I have 7 apples. So it's that one. Hello. You froze there for a second. Consider the compound rational expression. What is the best expression to multiply and divide by in order to transform to a simpler radical expression? It's the LCD. So just notice that this guy is a over x plus 2 minus b over x minus 2 times x plus 2 all over c times x minus 2 d over x plus 1. This leaves us with the LCD is equal to, well, it's the product of all the guys that you would see. So it's x plus 1 times x minus 2 times x plus 2. Looks like that guy. Suppose I want to simplify this. What is a good first step? Just square the expression to get that. No, you can't just randomly square something. That doesn't work. Notice that it simplifies to x plus 2. It actually does not. It simplifies to absolute value of x plus 2. What you would try here, just to get the actual answer out of the way, is to notice that, yes, the inside is a perfect squared, but we know that when we square root a square, it actually gives us the absolute value of the inside. So it actually simplifies the absolute value of x plus 2. So that's not going to write. Apply the square root to each term. We know that's wrong. That's distributing powers across sums. Solve that equals 0. No, you don't need to do that. So it's none of the above. Right? This actually simplifies the absolute value of x plus 2. And if you knew how to simplify it, you'd realize that, and none of these guys are correct. I think the picture got deleted here. 16. Problem 17 disappeared. Where did that go? Give me a second. Let me find that rogue thing. Because now I've cut and paste so often that that guy's gone. I'll have to put it back some other time. I think I lost it. Okay, note to self, put back problem 17, disappeared. I think I pressed the delete button by accident or something. That's gone forever. I'll just have to snip it from the website again. Okay, all right, let's just keep going. Suppose you know that this factors and one of the factors is that. What is the value of K? Couple ways to go about this, but I would just say if I know it factors and that's one of the factors, I would just expand. So I know that 6x squared plus 5x plus k. Now there are a couple ways to go about this, and I'll talk about this. Equals 2x minus 1 times. Now to get a 6x squared, I know that this must be 3x, but I don't know what the other number would be. That would be very important in me finding out what k is. So let's put y. Don't know what this needs to be. So what we can do then is multiply out. On this side, I would get 6x squared minus 3x plus 2xy minus y. Notice here, I would have 6x squared minus, well, let's write it as a plus y times minus, I want to factor out an x. I would have minus 3 plus 2y times the x. And I know that this guy here, this must be 5. So I get minus 3 plus 2y equals 5, because that's the middle term here. And so my 2y must be 8, and so my y must be 4. And so this means that my k must be minus 4, because my k is minus y. Alternatively, you could just try all the options. If you're very fast at factoring, that can work. Try all options for k. So in 6x squared plus 5x plus k, and you can try k equals 0 minus 3, 4, 1. And then you can try to factor all of them. So if k equals 0, then you'd have to factor this. if k equals -3, then you'd have to factor this. If your k equals 4, then you'd have to factor this. And if your k equals 1, then you'd have to factor this. And if you're really good at factoring, especially mental factoring, you can just realize that none work. Right, so like for this one, it would factor into x times 6x plus 5, right? And that doesn't mean one of the factors is 2x minus 1, and etc. And if this here was 2x minus 1, this would have to be 3x plus 3, and right, to get the -3, and that's not going to work. Here, if I force one of the factors to be 2x minus 1, this would have to be 3x minus 4, right? And that would give me, that's not going to work. That would make the middle term negative. And here, if I tried to force this, this would make this 3x minus 1. And that's not going to work. That would give a middle term this. So if I tried to force this in, the remaining factor would kill the fact that the middle term has to be 5. So you didn't even have to actually factor it. Just force one of the factors to be that, then you could definitely figure out what the other factor has to be like, because the constant terms have to multiply to give you the original constant term. But if I force that to happen, then the middle term doesn't work. So you'll realize that it doesn't work out with any of them. And yeah, and that's the test. Now, there were some bonus problems here. Which you didn't need to know before the test. I think today's lecture, I do go over lines and sketching them. And maybe in the last lecture, I went over the relationship between the slopes of perpendicular lines and etc. But we can stop there. I mean, I can continue and go through the bonus problems, but I will give you guys the option to leave if you have something to do. So I'll just spend the next few minutes and going over these bonus problems. But that is the test. That's what we actually went through everything that you need to know for the test. If anyone was curious that they tried the bonus problems and they want to know if they got it right, I'll finish up here. But for the rest of you, if you have to leave, that's okay. You can watch the recording of me going through the bonus problems, and that's fine. And I'll see you guys in the next one. So next week we don't have a quiz. We meet in Zoom, and you just have to continue. So I'll give you guys a break after this midterms. I know this midterms week was crazy. So next week it's just a matter of slowly learning again, and I'll see you guys. So note to self, put in back question 17. But for now, I'll just move on with the bonuses. Anyone who wants to stick around and see what they are can stick around. Okay, so GCF, this bonus was actually not so bad because we've actually done several examples like this already. The GCF, you always pull out the lowest power, right? So we know that it would start by pulling out the x to the -1/3, and then we'd write what's left over inside. So this is x to the 5/3 plus 1/3 minus x to the 2/3 plus 1/3 minus 2, well, x to the 0. So this would be x to the -1/3, that's x squared minus x minus 2. Yeah, And that's that one. So this was a very quick bonus problem, just to see who was paying attention. It's not even for a future thing, because we have actually discussed this problem several times before. So it was actually very doable, a very doable bonus problem. This one here, we haven't discussed before, but a lot of people would have remembered this from high school. So the equation of a line is shown. You want to tell me which equation it is. So we already know that the y-intercept is -2. So it automatically, by process of elimination, gets rid of those. So now we just have to find the slope. And for the slope, we just need to find 2 points that this thing goes through. So I know it goes through this point and it goes through this point. So if I create my little triangle, rise over run, that's 3 and 1. So the slope should be -3. And it's that one. Okay, let's move this down. So those two bonus problems were actually relatively easy, actually. Okay, here I gave you the equation, and you need to actually figure out what line it is. Now, the easy way to do this is to find the intercepts. For y-intercept, set x equals 0. You would get your y should be -2. For x-intercept, set y equals 0. You would find that your x would be +2. So I just need a guy that where the y goes through -2 and the x goes through +2. So it's not that. It's this. Done. Like you don't even have to look at the others. Yeah, so the bonus rounds are actually pretty easy. I think a lot of people could have tried the bonus and get some points back. Relationship between the slopes of two non-vertical perpendicular lines. They have the same slope. No, one slope is a negative of the other. No, one slope is a reciprocal of the other. No, there's no generation. It's actually none of the above. The actual relationship is the products of the slopes is -1. Or another way people say that is one slope is a negative reciprocal of the other. So it's not just the reciprocal, it has to be a negative reciprocal of the other. And I know because they're non-vertical, I would never like divide by 0 or anything when taking reciprocals. So the slope has to be like a positive or a negative number. So that's that. Here's another one. Find the center and radius. So we saw this as well. I talked about this on the bonus of the last quiz. You change the sign in the x squares when it's written. So instead of a -1 beside the x, you write as a +1. Instead of a +2 beside the y, write as a 2. So the center is +1, -2. The radius, what we would do is we would move this guy over here. It'll be 16, which is 4 squared. So the radius is 4. So that leaves us here. Now this last bonus is one that would take a little bit of computation, but I believe after I gave you a bunch of bonus problems where they're all like super easy, this one, it's fair of me to ask. Full 5 points. Find the so I know that this is like forms the diameter of a circle, right? So there's a circle that goes through this. Okay, so I need to be able to talk about the center, and I need to be able to talk about the radius. So we can use the formula for the midpoint. So the center is just going to be the midpoint. Of A is -2, 3. And B is 4, -1. So I just find the midpoint of that. That is going to be, you add the x's, divide by 2, then you add the y's, divide by 2. So the center should be at 1, 1, which on this graph, it actually looks like that. Then when you want to find the radius, you can just say that it's the distance between the center and either of these points. So you can say it's the distance between it's 1, 1 and -2, 3. Or you can use it as the distance between 1, 1 and 4, -1. Or you can say it's a half of the distance between the two given points. Either way, so they're all the same. So let's just actually pick one of these guys. So this means that your r is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the square root of, 9 plus 4. Square root of 13 is r. This means that your r squared is equal to 13. And so we know that the circle x minus 1 squared plus y minus 1 squared equals 13. And that's that. Okay, so that was that. Thank you for your attention, but we'll wrap up there. That was the first test. Hopefully you learned a lot about yourself, a lot about pre-calc, what it takes to actually do well in this. We will be going through a lot of topics moving on into the future, but overall, I don't think things are going to get harder, right? It's only going to feel new in some situations because I'm going to introduce new functions and new strategies. But once you have the basics down from chapter 1, like you really have it down, the rest of it should be fine. So if you're doing okay so far, I think you'll continue to do okay. If you haven't been doing okay so far, hopefully you're listening to some of the tips I've been giving you and you can actually make that a little better. That being said, we will wrap up there. Thank you for sticking around. And remember to watch lecture 14 today. That being said, I will see you guys in the next one. Ciao.